Don't forget to like the video and subscribe for more educational content. Today we're going to talk about early ideas in chemistry and atomic theory. The earliest recorded discussion of the structure of matter actually comes from Greek philosophy of all things. The Greeks postulated, these two guys right here actually, Leucippus and Democritus, postulated that everything was made of finite particles called the atomos, which means that they were indivisible. And if you're familiar with the word atom, you may see the etymology here. Atomos meant indivisible, but later their theories and hypotheses were usurped by Aristotle, who postulated that everything was made of fire, earth, air, and water, which were infinitely divisible. None of these actually tested their philosophical ideas, but while Aristotle had many of these claims reign champion for over 2,000 years, until John Dalton came around in 1807, who postulated 5 things, and many of his theories and hypotheses still hold valid today in modern chemistry. Dalton's postulates are as follows. 1. Matter is composed of really small particles called atoms, which is kind of interchangeable with the word element. That's as small as you can go before it isn't an element anymore, and thus chemical change can't happen if you try and go any smaller. 2. When talking about elements, any given element can only be one type of atom. Every atom of that element will have a mass characteristic of that particular atom across the board for all atoms within the element. And there are a lot of them. Later we'll talk about moles, which, if you know anything about a mole, means there are 6.022 times 10 to the 23rd atoms per mole. It's huge. We will get to that later, though. 3. All atoms or elements are different properties to each other. They are distinct. 4. Compounds exist. 2 or more elements can be combined in a whole number ratio. No matter the compound, a ratio will always exist in whole numbers within the compounds. 5. Atoms will not be created or destroyed, but rearranged in such a way that the substance created from the combination will be different from the 2 combining elements. To illustrate one of Dalton's theories here, we're going to actually go with a familiar molecule that we like to call water, or, dihydrogen monoxide. You may understand the joke there. So we have 1 hydrogen, 2 hydrogens, and we have an oxygen. The oxygen is actually much bigger than the other 2. So we see that we have whole numbers here. These can't be split in any way. We have 2 here, and we have 1 here. We can combine these because electronegativity will come into play later, but I was about to say something about that, but we'll let it go. Whole numbers, 2 here, 1 here. By themselves, they are very flammable. And if we combine them, we can see that we can move this over here, and we can actually think of this as an equation too. We can actually just, hold on, let's make this red. We can actually just add a little plus sign right here, and an equal sign, and 2 plus 1 is going to equal the whole, which is 3, or 0, 0. I'm not doing very well at picking my colors, am I? Is going to be equal to color picking here, something like this. See you guys in the next video. Be sure to comment and discuss further about Dalton's theories. Also, if you'd like to support the channel, in the description there will be links to things that can help support the channel, as well as the link to the further resources to the material covered here.